let me just share my screen and we can get started. Okay, let me just present this. Is this visible to everyone? Cool. Okay. So as it was already mentioned, this is the title of the talk. We'll be talking about how we can analyze annual reports. First, we'll be discussing what annual reports are. This is for people who are interested in both finance as well as NLP. We'll be doing a bit of both here. So a little bit about us. So I work at Auquan. So we are a fintech company who provide data science solutions for institutional investors. We do it a bit differently in a way that we convert finance-related problems to machine learning problems. Then we have a platform called Quest, where we put those problems, and our community of 15,000 data scientists solve those problems, and we generate the best possible solutions out of all we get, and then we generate a final solution for the client. So in that way, we ensure that our final solution has been crowdsourced and it is the best possible solution for that particular problem. I was talking about this in the beginning. So this talk is about NLP, a very specific application of NLP in finance. Then who are supposed to attend this talk, anyone who is interested in NLP, they'll get to solve a problem as we go along. Anyone who is interested in finance, they'll be able to use this knowledge in their daily work if they are interested in NLP. So this is a small version of what we'll be discussing. So first we'll talk about what we'll be talking about and why we are talking about that, about annual reports and why are they necessary, why we are doing what we are doing, and then we'll move on to how we will be doing what we'll be doing. Cool. So a little bit about the problem itself. So in most of the financial institutions, there are hundreds of analysts which sift through lots of reports. These reports can be annual reports, reports bought from other vendors, any form of data, and they need to go through each of them manually and form their opinion, and on the basis of their opinion they formulate some strategy to trade, and finally then the trade happens. So there's a lot of data for that. The research reports, company filings, transcripts, quarterly earnings calls, and then there's also general news. There is no end to general news, it's just so much. So all this has one major problem, that it's just way too much data, especially in the current times of social media. If you want to extract any knowledge out of that, you cannot just manually read and find out anything from that. So suppose you were an institutional investor and you wanted to look at 1,000 companies. There's just millions of documents that you will need to read, and it's just not scalable for you to hire more and more analysts to sift through that data. So it's just not possible. Yeah, so this infographic shows you how the data has grown. The unstructured data has grown over the years. So unstructured means any data that is present which is not in some specified format, which is the most of data. All the pictures, text that just happen to be on the internet is unstructured data. So as you can see, the data has grown exponentially. It has become really difficult to obtain signal out of that data, and it is just not feasible to manually go through documents and identify important stuff from those documents. Okay, you can. So if you have any questions so far, you can just write it in that document which was shared. So we are making a case here that NLP is no longer a good to have, but it is a real necessity, because if you want to be better than everyone, if you really want to be a market leader, you need to have all the information. And to get all that information, you really need to go through all the information that is present and identify the most relevant. And that cannot be done manually. You really need NLP for that. And in this talk, we'll be focusing on a specific way of extracting information. We'll be extracting relevant information from annual reports. So let's talk about what are annual reports. Those who have some sort of finance background might already know about it, but let me just go through it. So this is a Wikipedia definition of what an annual report is. It is a document that gives you all that is to know about a particular company, public company. Even private companies also give out annual reports, but public companies are mandated to do so. So it contains information about their financials, their relationships about other companies, all their clients, what are their profits and losses, any new deals they have cut, any legal ramifications they might be in, anything remotely relevant for an investor. So as you can see, these are some of the annual reports I've shown here. So they contain a lot of graphics and text, and they are pretty easy to read. They are generally longer, 300 to 400 pages, but you can still go through them. But how easy is it for them to be read by machines? Because we want to automate that process of extracting relevant information from these reports. Turns out it's not so easy. There are lots of different types of entities in an annual report. There are tables, there are pictures, there's text of different formats. There is no well-specified format, and they are not arranged in a way that is understood by computers easily. So if you directly want to extract something out of it, it's really difficult, and we'll get to doing it and see why it's difficult. Then, like I was saying before, there is no well-specified format. In US, there is a format called 10K where it is mentioned what all you have to write in your annual reports, and those sections should be there. But in Europe and any other place in the world, there is no such format. You can organize your annual report in any way, in any format. You can. It's really difficult to compare annual reports of two different companies, or even compare annual reports of a company between 2 subsequent years. So yeah, that's a big problem. Yeah, so this is something that I found really interesting. This is called Hathaway effect. It was discovered by Cord Jefferson in 2011. So what they found was whenever Anne Hathaway was mentioned in news, stock price of Berkshire Hathaway went up. And their hypothesis was this happened because the naive systems were just searching for a keyword Hathaway, and whenever they found it, they traded on that, and the stock price just went up. So yeah, this has been a problem that has been discovered in the literature. Yeah, so I found it pretty interesting. So this is a problem of correctness as well. Even if you are able to extract entities out of news or any document, it is difficult to extract them out correctly. And that can have unintended consequences, as we have seen. So a summary of what we have discussed so far. Annual reports are meant to be read by humans, and it is not straightforward. It is, albeit difficult, for them to be read by computers. And even if you were able to read them, it is still more difficult to extract relevant information out of them, as we discussed in this case. Yeah, so we have talked about that it is difficult to read annual reports by computers, and it is difficult to extract information from them. But what all information can we actually extract? So you can extract financials of the company, all the profits, losses, EBITDA, all those finance-related terms. Then you can identify their relationship with other companies. So for example, if you are going through annual report of Microsoft, you will be able to find that LinkedIn is their subsidiary, or any other company, or GitHub is their subsidiary, or they have some working relationship with Apple regarding Microsoft Office and things like that. Then all the events and incidents, so anything happened. So for example, if you read Apple's annual report, you'll find that they were involved in a lawsuit with Apex Games. and things like that. So anything relevant for the stock price of that company, you will find that in annual report. So yeah, like I mentioned, there's a lot of information to be extracted out of annual report, but we'll be focusing only on extracting relationships because given the time, that is the most easiest, that is the easiest thing to explain. But using the same principles, you can work towards extracting the other stuff as well. Okay, so why we are trying to extract this information, extracting relationships. So for example, so identifying entities is actually the first step in anything that you want to do later. So suppose you wanted to train a machine learning model to predict price from annual reports or from news. Just directly training on text won't give you good results. You need higher order information. So for example, this is just a piece of text, but you'll need to identify that this Apple refers to an organization that is named Apple. Tim Cook is the name of a person. Tim and Cook are not different words. They are one entity who is a person, and similar to Cupertino and Flint Center. So they give you higher order information to train against. Then you can also identify core movements between companies. So like I mentioned about business relationships. So for example, if Microsoft mentioned that they have a business relationship with some company who is dependent on some of their product, then their stock price might move together, because if there's a problem in one, there can be problem in others. I mentioned an example of Qualcomm here. So Qualcomm manufactures chips for a lot of mobile companies, probably almost all of them. And if there was some problem with them, it might lead to problems with others. So yeah, you can identify companies whose stock price might move together. Then you can also identify the different direction of movement. So suppose we were looking at Nike and Under Armour. If from annual report of Nike, you were able to identify that Under Armour is a big competitor, then you can probably say that when Nike will go up, Under Armour will go down, because clothing and sports merchandise is a pretty saturated market. So if someone gains, someone loses. So yeah, all this information you can obtain by doing what we are going to do here today. Okay, so we have talked about what we are going to do and why we are going to do it. Any doubts till here? Yeah, you can write that in the document. We'll come back to that later. Now let's move on to how we'll be doing what we have talked about so far. So this infographic tells you the general pipeline as to how things move, and almost everything in NLP works in the form of a pipeline. You have small frameworks that take care of some things, and then you just create a pipeline out of them, each doing a particular step, and finally you have what you need out of it. So first step is, as we can see here, is PDF to text conversion. So all the annual reports are in PDF format. Then there's an exception. In US, they also provide 10K reports in a different format, in a structured format, but everywhere else you have PDFs, and even if there's a structured format, PDF will still be there. So your first job is to extract text out of annual reports. We'll be only focusing on text and not images or anything else. Why we are doing this? Because machine learning systems can only, on the basis of the current research in machine learning, the systems are able to work with text and not directly with PDFs or images created from PDFs. So there are two possible cases. Either there is extractable text in your PDF, that is around 95% of the time that will be the case. If you are out of luck and the company has just put in a scanned copy of their text, then you'll have to apply the second one. So in the first case, when there is extractable text, there are several libraries available in Python. Each of them work well in different cases, so you might have to try each of them to see whatever works for the annual reports that you are working with. But it doesn't take too much time to try each of these, so you can try. If you are using Python and you are an old style person like me, you can simply install popular utils and use PDF to text. this works out pretty well. So if you don't want to try all this, you can directly use this PDF to text. It really works well in most of the cases. Then we come to the case when you're out of luck. There you need to do OCR recognition. OCR stands for optical character recognition. It is a method of extracting text out of images. So there are several libraries for that. You can try them, and some of them work really well. Tesseract is open source, and there are proprietary ones as well. So you won't be needing this most of the times, but yeah, if that's the case, you can just go with any of them. So let's look at an example. This is using PDF to text, the one mentioned at the end. So this is the annual report of Marks and Spencer for 2020, and this is the text that we obtained out of it. So as you can see, it is not well structured. It has just taken all the text and dumped it in a text file. No formatting, nothing, just the raw text. So as you can say, we are not missing out any text. We have just lost the formatting, and that's what you will find with most of the annual reports. Now, second thing that we are moving on to is named entity recognition. So as the name suggests, it is the process of finding all the people, organizations, locations, and any other named entities that are present in text. So currently we have this piece of text and we know nothing about this text at all. Now we are trying to identify if there's any people, companies, or any other organizations or location mentioned here, like I showed you before in that Apple example. Why we are doing this? Because language is just too complex for a direct keyword search. We'll run into same Hathaway effect problem. Cool. So I have some examples to show you here. So suppose you had a system that was looking for Philips. You were trading on Philips. So these are two news items. Actually, second one is taken from Wikipedia, just for example. But Philips occurs in both of them. But in the first one, it happens to be name of company. In the second one, it is a person's name. If you directly do a keyword search, it doesn't really differentiate between the two. Your system will fire for both. And if you are directly using that as a signal, you'll trade on a wrong signal. Here's another example. So Total is an oil company, and there's a news about Total, and there's another news close to where I live, and both have the word total. So if you were looking for this word, your system will fire in both. But here it refers to a company. Here it is not even a noun. So there can be a lot of such problems. These are just a few examples. And if you trade wrong on even a few of these, you might lose a lot of money. So what we have established so far is directly searching for a keyword related to a company or a person can give you a lot of fallacious results. And so you always need to run NER model first to just be sure that what you are searching for is actually what you are searching for. Then let's look at what NER models to use. We have just talked about what we'll get out of those NER models. So these are the two that are used the most. Spacey is currently now a standard tool used by any NLP researcher. There are some older ones as well, Stanford NLP and few more, but they are pretty old. Spacey takes care of a lot of stuff that you'll need to do. So I would recommend getting started with this. It's really, really simple to use. They call themselves industrial strength natural language processing library. They have really good support, and it's open source. It works really, really well. Then it just doesn't do NER. It provides a lot of other functionalities like POS, parts of speech tagging, dependency parsing, and a lot of other stuff that we are not going to discuss today. Then there is Flare. Flare is a recent one. It is more of a research thing. It is developed by Humboldt University of Berlin and friends. An advantage with Flare is that it contains the most recent models. So if you have tried Spacey and you want to improve your model's performance, you can move on to Flare and you will probably get good results. better results than you have here. Models are a bit buggy sometimes, and it takes much more work to make them work, and might not be suitable for production in all of the cases. But yeah, they have pretty good models. So yeah, like I was saying earlier, you can get started with spaCy, and if you really want to improve your systems further, then you can move on to FAIR. So I have prepared an example, a simple example using spaCy. So yeah, let's just go through it one by one. So in line 1, we are just importing spaCy. In line 4, we are loading a model pre-trained by spaCy. So EN stands for English, core and web are just needed to identify that model. LG stands for large. So there are also SM and MD, which stands for small and medium. So you can try those if you're out of memory or something like that. So you can load your model this way. Then what I'm doing is I'm just converting each of the pieces of text that we saw earlier into a spaCy doc, and then I'm just printing the named entities out of those documents. Let's look at the results. In the first one, the results are starting line 15. So for the first doc, which mentioned Philips as an organization, it correctly identifies Philips as an organization. So if you ran this model, you would know that that's a company. You won't know that's a company, but you'll know that it's an organization. Then in the second case, where it was a person, it correctly identifies John Phillips together as a person, as one entity. So yeah, it's just that easy. You just need to import it and it will work in most of the cases. So here we have done it just for a single sentence. We'll talk about how to do this for a large piece of text, because as we saw when we converted annual report into text, there was a large piece of raw text that we obtained. These are the steps that you need to follow. First, read the whole text as a spaCy doc, then break it into sentences using spaCy itself. I'll show you how. Then for each of those sentences, apply NER like we did in this example, and then get relevant entities for each of the categories. So suppose you are looking only for organizations, get all the orgs. If you're looking for people, get all the persons. And yeah, it's just that simple. So if any questions here so far, feel free to add to that document. Then let's look at an example for sentences. I'm reading the text from file, that same file we obtained by converting PDF to text. I'm converting that whole text into a spaCy doc in line 13. And then in line 16, I'm just printing each of the sentences that has been identified by spaCy. So like we saw earlier, in this text, the text is not structured at all. It's difficult to identify for an algorithm as to where a sentence begins and where a sentence ends. There is no structure here. There are end lines anywhere. There are no full stops at most of the places. So yeah, spaCy does a really good job of identifying each of the sentences. So here's what we obtained from Marks and Spencer. So as you can see, for some sentences, it really worked well. So the first sentence starting from today and ending at globally, it identified it perfectly correct. In the second one, it just stopped in between. But in most of the cases, it will work out pretty well. Then here are the named entities that we obtain using the code that I showed you earlier. As you can see, Richard Price, Alison Britton, we are able to identify them as people. Then Tamara Ingram, that has been wrongly attributed as an organization. That will happen because models are just approximation and they won't always work. But it is still better than keyword search, and you will be able to identify a lot of companies this way. So for example, here we are able to identify Ocado as an organization. And yeah, that is how your results will look like. So some notes, like I have touched upon these before, but I'll just repeat them again. So like I mentioned earlier, this won't always work. You will get a lot of wrong categories. Sometimes people will be marked as organization and the other way around. but it works well 70-80% of the times. That's the accuracy on the large data set that we found. And yeah, so just as an exercise, here we did it using Spacey. You can go back and do the same using Flare and compare the results if you make any improvements. Yeah, so let's move forward into another problem. So currently, we have been able to identify organizations, people, etc., or any other named entities from text. So here are three. Suppose these are three entities that we have been able to identify: MNS, Marks and Spencer, Marks and Spencer PLC. We know that all three are same organizations, but we don't. Our algorithm doesn't really have that information so far. It would have marked each of them as an organization, but it won't know that they are same organization because the names are different. Then suppose you have a database in which you have Marks and Spencer stored as a business with some ID. So people who are not familiar with finance, these are just names of some IDs, some unique identifiers for different companies. So suppose you have Marks and Spencer stored as a business with any of these IDs, and you identify these three entities in any piece of text, say news, that you were considering. Now, suppose you wanted to identify how many times Marks and Spencer was actually mentioned in that report, in that piece of text, in any text anywhere. Could be news, could be annual report, could be any research report, anywhere. So how would you do that? Because if you directly take counts, you'll just, for Marks and Spencer, you'll get only one. For MNS, you'll get one. And Marks and Spencer PLC, you'll get one. So finally, in your database, you only have Marks and Spencer. So you'll say Marks and Spencer has occurred only one times, but in fact, it occurred 3 times. How to correct that problem? There are 3 ways. Actually, these are 3 steps. You'll need to do each of them. So first is yeah, let's go through each of them. So first is enriching your database. So from our previous example, you had Marks and Spencer in your database. You identified MNS in the document. Using any string matching algorithm, you cannot say that these two are the same entity. You just cannot say. The strings are just too different, and you cannot compare and say that MNS is Marks and Spencer. If I didn't tell you that and you didn't know about Marks and Spencer, you wouldn't know that. So we cannot expect the computer algorithm to do the same. So the only way to achieve it is by adding Marks and MNS to your database. There is just no other way. But thankfully, that is not so difficult to do. There are lots of open databases that you can go to. You can obtain all the alternate names for each of the companies, and then you can just simply add them to your database. So here's an example from Marks and Spencer from Wikidata that is openly available. So yeah, here we see that MNS is mentioned as a alternate name for Marks and Spencer. So just take the names from here, add them to your database, and you're good to go. Yeah, one of the problems is solved. Let's move on to the other ones. So the steps mentioned in this slide are pretty subjective, and my advisor used to call them black magic because they just come from heuristics and experience. It's difficult to formalize them and say why they are working when they are working, and yeah, just difficult to say when they will work and when they will not. But in most of the cases, they will work out. In some cases, you will get some false results, but that's the case with any algorithm. Cool. So let's just quickly go through each of them. So first step is removing the accent. There's a library for that. Removing accents from the names, it's pretty simple. Then removing the prefixes. So if you have a company starting with the or you can just remove that prefix. Then removing suffixes. So you must have seen that companies have GmbH or Inc. or Group mentioned at the end of their names. You can just remove out those to match properly. Then, yeah, this is probably the simplest. You can convert everything to lowercase or uppercase just for the ease of matching. Removing punctuations, removing special symbols, that also works pretty well several times. Yeah, as I mentioned before, in general, you will be fine. In some cases, this will cause problems. Okay, let's do this for the company, for a different company now. So suppose you had L'Oreal, the second one in your database, and you identified the first version with all the accented text in your document that you were trying to extract information from. First step is removing the accents. So we remove the accent from both. The second one didn't have any, so it remains similar. From the first one, we get this. Then we remove the suffixes. So we remove the SA, and we have the same name. Now they will match. So you can say that, oh, this L'Oreal is similar to the L'Oreal that I have in my database. So yeah, this will work out for most of the cases. Some thoughts here. You'll need to normalize both names in your database as well as the names that you identified in a document, and then apply each of these steps. And at any step, if there's a match, just stop there, don't go further, and this will work out well. There will be a lot of cases when you normalize too much and it will match with the wrong company. But if you just stop initially, the algorithm will just work out in most of the cases. So yeah, that was just too much content. Let's summarize what we have done so far. We have learned how we can convert PDF to text. We have learned how we can extract named entities from text. We went through a few examples doing that together. Then we resolved those entities with our database. So if you identify some variant of a company in some text, now you can normalize and match it against your database. So you would know that MNS is also Marks and Spencer. Marks and Spencer PLC is also Marks and Spencer. So if you need to count how many times Marks and Spencer occurs, you can easily do that. Yeah, so okay, why we are doing this, the counting thing. This goes back to the problem that we discussed in our few slides, in our slides in the beginning. Analysts have to read through a lot of reports. We want to automate that process. So, but if a computer, a machine was able to do all of this, extract relevant entities from a piece of text, then an analyst won't need to go through all of it. He can just read the most relevant parts. And in several cases, you might be able to even train machine learning algorithms on top that will do automated trading with some human expertise, of course. So what we can do using what we have done so far, we can count how many times a document mentions a particular entity. So like we did earlier, we can count how many times a document mentioned Marks and Spencer. So how is this helpful? So suppose Microsoft was mentioning some company in their annual report a lot of times. That might say that there is some relation between Microsoft and that particular company. Otherwise, why would they mention it so many times in their annual report, which is probably their most relevant document? And there's also other case of news. So suppose two companies mentioned, are co-mentioned a lot of times, then probably they are related in some regard. They probably lie in the same sector. They are some business partners. They might be competitors, but they have some relation. So if we are able to count, we'll be able to extract that, yeah, there might be some relation between these two particular companies. We still cannot say what that relation is, but we can get some signal as to there is some relationship. Yeah, so this is what I mentioned that I was just talking about, that number of occurrences can be a proxy for strength of relationship. But yeah, we haven't discussed how we can extract the exact nature of relationship. And by exact nature, I mean whether the other company is a subsidiary, is a business partner, is a competitor, a client, or just any other relationship. We'll not be doing it in detail, but let me just introduce you as to how it is done. There are two major ways. First is sentence parsing, and then there's a supervised approach. Sentence parsing, this is more of a classical approach. Breaking text in the form of a tree is what has been known to NLP researchers from several years. And this is what has been done for so long until deep learning came into being. And yeah, so you just take your sentence, identify all the categories of different words, and then you give a structure to your sentence and try to identify what refers to what. So for example, in a sentence, you will try to identify which is the subject, which is the verb, and which is the object. So for simpler sentences, if it said LinkedIn is a subsidiary of Microsoft, then you'll have subject as LinkedIn, object as Microsoft, and and the verb as subsidiary. So using that, you can say, okay, the word subsidiary might refer to subsidiary. So LinkedIn is a subject. So LinkedIn is a subsidiary of Microsoft. So this way of structured parsing. Well, it works out for simpler sentences, like I mentioned, the example I gave now. But financial documents have really complex language, and this breaks pretty quickly there. So I won't bet on it to work there. But yeah, it's just good to know about that something like this exists, which you can use out of the box. Yeah, I am a big fan of this code, and I have personally experienced this in my work. Whenever you are working on some project which requires you to put in a few weeks, it's always better to prepare a data set going manually and preparing a supervised data set than to trying to make an unsupervised algorithm work. There are several reasons for that. In my personal experience, one of them is that you'll know that you are making some progress. With unsupervised algorithm, you'll just run it. You'll see, okay, the outputs are looking good. Next time you will make some change, you'll run it again. And you cannot see so much data to make, to identify if your algorithm worked well for all of the data. And you will just, on the basis of your biases, say, okay, this is working better than before or not. And you never know if you are making progress or not. So it's always advisable to first go create a data set that you will hold yourself accountable against, and then go and train your model. So yeah, always keep this in mind. Okay, so now let's do just that. Let's train a supervised model. How do we do it? We have been able to identify all the named entities. So just take all the sentences that mention those named entities, take them together, concatenate them, and just pass them through any supervised algorithm that predicts anything from text. There are lots of supervised models that predict from text, and you can just use any of those. There's not a lot of research done here. So let me explain you in detail. You'll have all the sentences. You'll have a classifier, any machine learning classifier. You can use the recent deep learning models, BERT, the older models, TF-IDFs. There's just so much there. And you can just take those sentences, pass them to your classifier, finally try to predict whether that company is a client, a research partner, a competitor, or whatever. Where will this data come from? If that company is a client, research partner, or competitor, you'll have to go and manually do it yourself. There's no way around that. In my experience, I've never found a data set which mentioned these. So either you can procure such data set, or you can just manually go and mark for thousands of companies, and you can just train a model and hope that that model will generalize and will be able to identify the same from other text. That's the best way of identifying relationships from text, if that's really important for you. Okay, so I think we have gone through a lot of stuff. We have seen a lot of examples. Let's try to conclude what we have learned so far. So as simple as it might seem, correctly identifying entities from text, annual reports, news, is not as easy as it sounds, and a lot of people get it wrong, like we saw in that Berkshire Hathaway example. But the task is still sufficiently doable by using state-of-the-art machine learning methods. And if we deploy these methods at scale, then our analysts won't have to go and sift through thousands of reports. We can reduce, at least if not completely eliminate, reduce the data set that they'll have to look into. And yeah, that's mostly what I I have taught you today, you will be able to achieve. And yeah, that's mostly it. Any questions?